Okay, development of lateral surface of cone, diameter 50 mm and axis length 60 mm. So you can see here we have constructed the both top and both top weave and the front weave of it. So we can see here R defines the radius of the cone, radius of the base of the cone. Okay, smaller, and H defines the height. Height is nothing but axis, and capital R is nothing but the generator length. So how to construct here? You can see here sector AB length. We will be how we are going to find out. You can sector AB is equal to capital R into small theta. So theta will be is equal to sector AB by capital R. So sector AB length we will be considering that as a 2 pi r. Okay, 2 pi r, and then we will consider 2 pi equal to 360 degree. We know pi is equal to 180. And then after that capital R we are going to find out, that is generator length. So generator length we are going to find out using Pythagoras theorem. You can see here capital R is equal to root of small r square plus h square. Using Pythagoras theorem we have found out. Then we have the R value, radius value 25, because diameter it is 50. Is substituting the values, that is R value and the H value. H is 60. So the angle we get is, that is 138 degree. So first I will be considering this length. First I will take reference point. Then I am going to measure this length. That is your generator length. Okay. So I'll be drawing that length. Okay. Then I have to sweep at an angle of 138 degree. You can see here. So we'll be considering a reference point here. I will be marking at 138 degree. So 140 it is, 139 and 138 degree. Okay. So till here how to sweep. Okay. So you can see here. By taking this length, so we are going to sweep till here. Okay. So then joining to this point till here. Okay. So you can see here, this is what theta, this is what capital R. Okay. So this is how we complete the lateral surface of the cone here. Here in the problem, a cone of diameter 55 mm and height 75 mm given. It is resting with respect to base on HP. So it is cut by a section plane here at an angle of 45 degree to the axis, and it is occurring at a distance of 40 mm from the apex. So we need to draw the development of this truncated cone. So first we draw an XY line. We draw an XY line here. And we take a compass and measure 27.5. So diameter 55 means, so we will consider the radius of 27.5 and we will draw an circle here. Okay, draw an circle. So diameter it is 55. So that means we need to consider the radius of 27.5 here. Okay, so 27.5 we should consider, not 55. So you take a 27.5 from the scale and construct the circle. Okay. So now you can show the dimension on one side. Okay. So after showing the dimension, we were going to construct, we are going to divide the circle into 8 equal parts. Okay, so with the help of the scale we can divide the circle into 8 equal parts here. Okay, so I'll be marking for an angle 45 degree and 45 degree on either side. So 45 degree here and here 135 degree. Okay, so then I will extend these lines. Okay, okay, so you can mention the naming A, B, C, D, E, F, G, H. Okay, now project the lines here. So project the lines on the XY line. Okay, so you need to draw an axis for a height of 75 mm. Okay, so draw an axis for 75 mm. So here the front view of the cone, it is a triangle. So the inside lines you can show with the thin lines here. So these are generators. So you can mention the namings. So from the front view, which are the faces are visible, you can write without brackets. The things which are not visible, we are going to write within bracket. Okay. So we can mention the axis here. The axis height is 75. Okay, so we should consider a section plane in the axis. Okay, at an angle of 45 degree, exactly the apex, from the apex we should consider. So that is at a distance of 40 mm. Okay, so now we can keep the protractor there. Can show the dimension 40 mm from the apex. Okay, so take the protractor and mark this reference point and mark for an angle 45 degree. Mark for an angle 45 degree. Okay, now draw a line, section plane, passing through this angle point. So cutting all these edges, all these generators, you can say that. Okay, now you can show the angle. So after showing the angle, you can dark the cutted portion. Okay, you can dark this cutted retained portion. Okay, so you can dark this. Okay, can dark it. I can mention the naming now here 1, 2, 3 where the actually cutting is occur. Okay, 6, 7, 8. Okay, so now we can see we need to show the true length. So true length we are having at the one end, and the same true length we have taken. Okay, now we will be constructing an arc here. Okay, we'll be constructing an arc here. Okay, you can measure the distance from AB. So you can measure any one of this length and you can cut the arcs. So each of these lengths were same. You can measure any one of it and you can cut it. Okay, so it's all drawn with the true length of line. You can see that all those marking 1, 2, 3, 4, all those things are projected on that true lengths. Okay, from there we need to measure the length. Okay, You can mention the namings here: A, B, C, D, E, F, G, H, and that is A. Cut and extend. Okay. So now you can just extend that the curve so that it is cutting the arc. Okay. Now you can join all this with the vertical edge. Okay, so now we need to measure the length. Okay, that is 1 2 3, all those I will be projecting on the true length, so all these points, so that it is easy for us to measure the length and cut the arc on this. Okay, so I will be measuring point number 1, so it has to be measured on the true length, so remember it. So we need to cut it on the A point here, so on the A it will be the 1 1. The same way we need to measure 2 and 8 here. So 2 I will be cutting on the vertical line B, and 8 I will be cutting on the H. Okay, in the same way I will be cutting the 3 and okay, the same way all the lengths were I am measuring it 4 and 6. 4 and 6 also I am going to measure. Okay, now we have left with the point number 5, so we are going to cut it. So you can mention the name and numbers here, so that is 1, and here also 1. Okay, so you can mention the namings, so that is 3 and 7, 4 and 6. Okay, that is 5. So now we have to join all these. So here exactly you can use scale or using a curve you can join this, because it is a cone here. You can use the curve here to join these, all these points you can join with the curve here. Okay, so now we would dark that retained truncated portion, so we need to dark this. Okay, you can take the compass and dark that lower portion here. You can dark that, so that completes the problem.